About 51% is taxes in India, in petrol. But in diesel, it's the story the other way around. The price is actually very low, and that basically makes it whatever we discussed so far. And this is about the blending requirement if you have ethanol. And I'm not going into details because my time is almost running out. We have the next guy coming in. So this is what the biodiesel requirements and all. What is the scenario looks like. These are the present status. We talked about mandatory blending, but then we gave it up because it's found feasible. The procurement price in 2011 was fixed at 32 rupees, whereas the international price of petrol is about 45 rupees or something. Committee has been set up. Again, not very positive things so far. We are not able to do much in biofuel things. The other part that we now are going to the power sector a bit is one of the ways besides the biofuels and all is also about conservation. How can you conserve, and especially I'm coming to power, where petroleum product is not feasible to do peak load pricing. Peak load pricing, maybe you know in power sector is time of the day pricing. And that's one of the interesting ways in which you can actually reduce overall requirement for the power consumption. What you basically do is, I think you may be aware of already this in microeconomics, you might have done it already, I'm just repeating possibly, is that in the peak hours, start charging a higher price. Because the price elasticity of demand is low, people will not be able to get away by, they'll have to pay a higher price. Whereas if you are in the off-peak hours, charge a lower price, because that time there's an excess capacity available. The power plants are not getting used to the full capacity because they are designed to also meet the peak demand. So off-peak, obviously demand is less. So that time consumers may be wanting to shift their the price elasticity of demand is higher. That is one way you can. So what happens? What happens to the revenue of the company? In the peak hours, you're getting more revenue because your price is higher. Quantity sold is roughly the same because there's a peak. In the off-peak hours, what happens? Quantity sold is actually less because off-peak people are not buying power. But if you reduce the price and the price elastic demand is more, what happens? People will start shifting the demand pattern from the peak to off-peak. At the moment that happens, automatically power industry becomes more profitable. So a lot of the people in India were not paying for the power and all. And many of the, that's basically true for the retail level household, small customers and all. But all the big industries and all paying up because you still have power sector going on. And I give you an example of Delhi and many of the cities and all, where the distribution has been privatized, and that has really made the sector very, very attractive for the private sector. Because one of the company, BSCS in Delhi, has been kind of offered that if your PV is not profitable enough, you can walk out. But obviously they know it's very profitable, so they don't want to leave the business. So that's one of the interesting things. Gradually, Delhi experiment, I'm hoping, will be replicated to other parts of the country also, and that should be able to help. If you have time of the day, privatization, these things happening. Because what happens the moment you privatize, what happens immediately? The losses, the power distribution losses and all, significantly come down, because the thing is, the private company is worried about the profits. And that obviously is going to be main consideration for them, that the leakage of power is minimized. And that basically has happened from 55% of power loss in Delhi to about 15%. That's a huge improvement. And I'm kind of not very surprised why this cannot be replicated to other parts of the country. Because I don't buy this argument that people are not willing to pay. The moment you give them a good quality power, I'm sure people are willing to pay. Because the thing is, if you don't get the power, how do you manage? You have the captive power plants, which are very expensive, polluting, noise pollution and everything. The moment you have power available, there's no reason people will shift from existing diesel-based power generation to the grid, which is basically still economical, because there are huge economies of scale in the power production, as we discussed in the previous session also. Because although you're shifting the pollution, but again, one is the pollution shifting from one location A to location B. Second is, if you have a bigger power plant, obviously the capital cost is divided by the total output, makes it the fixed cost very, very small, and that makes it power production very economical. So the ultra mega power plant which have come up in the last few years, and more are on the cards, they actually are able to provide power at a very, very cheap rate. And that, in a way, I believe is another way to go forward. Time of the day pricing, big power plants, and privatization. And this is happening, but little slowly. But I guess soon, when the we are closer to the crisis, more things are likely to happen, because the moment people see the benefits, they are obviously ready to kind of participate and do not resist the thing which they have been resisting so far. I have more slides. I think I'm running out of time. This is a people pricing diagram now, which I'm not going into details. And there's some example of the US steel industry, which again I've taken from Tim Harford's book on crosstown traffic, which is a very interesting example of how the companies respond to the market-based solutions, and that has been very, very successful. And China has been experimenting with the same ideas, learning from the US, and has been able to do something on the pollution front. And that has also reduced the energy consumption by the steel industry significantly, by almost 40 to 45% reduction in the energy use.
What is that experiment? Can you
Experiment is basically it started with pollution. That you say that I'm giving you a permit to pollute this much. If you want to pollute more than this, then there will be a market. Just like a Kyoto Protocol mechanism.
You're talking the hard
same kind of a
crosstown.
The Hartford one.
Crosstown traffic is the title of the chapter.
Yeah.
Traffic. What is the traffic problem? It's basically a congestion, pollution, and all. So this chapter goes into the solution, starts the traffic, and then goes on to the actual steel industry example in the US, China, and other places. So that basically, this chapter gives you the idea. This is basically a case study based example from this chapter.
What do they do? What do they suggest?
They have, the EPA in the US has developed a carbon credit kind of a mechanism like the Kyoto Protocol for the steel industry in the US. And that all the company today, like you're polluting this much, you're given the license that you can pollute this much, but tomorrow you have to reduce your emission by 10%. So where do you get the kind of extra permit to pollute? You have to buy it from the market. The moment you buy it from the market, what happens? Initially the companies claim, as you can read in the details, that to reduce sulfur dioxide by 1 ton, they require about $250 to $700 per ton. This was the claim by the industry. And actually when the EPA went ahead with the market mechanism, the per ton price of reduction of the sulfur went down to 70 rupees. The market price was 70 rupees, $70, sorry. And that shows that if the moment you have the market solution, and at $70 also companies are not willing to buy it, which means possibly it's even cheaper to reduce pollution. And that later on also gave them a lot of benefits about energy usage and all. Their energy conservation improved and their costs went down. And then suddenly, which looked completely infeasible solution by this market mechanism, which is basically your solution about the Kenneth arrow, about the first slide which I showed you, that basically was applied here and with very, very kind of amazing results. And now a lot of these stories, I think somebody needs to possibly develop a consultancy kind of a thing, EPA something in the US and all, or maybe China is now learning from this experiment. And I'm sure India can also learn, and many other countries from this can learn. You can reduce your energy consumption plus also reduce your pollution requirements. So that's what I'm kind of hoping, that a lot of these solutions, which are purely from economic theory, can actually be really, really practical.
There is recently, is a case in where China and India both refused, because in Europe now they have what we call pollution tax. So the airports have installed this pollution tax, and they say if your aircraft lands in any European airport,
that's
they have to pay an additional tax.
Yes.
So China and India has refused to pay that tax.
Not just China, India, even US has refused to pay.
So okay.
So
3 countries have refused.
Almost from there, all the countries are kind of saying, why should we pay? We'll put a set off on you if you put it on us.
So I can't understand how it can work in one way, because in other words, you see European planes when they land here, they have to pay the same thing. Because all aircraft.
This is especially for pollution only.
No, but aircraft pollute in the same way whether it flies to.
Yeah, so that's the kind of that's what China-India argument is the same. That we are saying
the same plane.
Yes.
So it ultimately it balances out on its own anyway.
Yes.
So I don't see the logic. I don't know if any one of you have any.
So basically, it will increase the cost of travel, because in India you don't have a specific EPA tax. Already the cost of travel is very high. So if you impose another component, maybe 2-3% of it, it will be additional cost for the passenger.
But you see, within the internal airlines, if you do that, you say you don't pay. So it has no impact. So it's only on foreign aircrafts, isn't it?
But still, it's going to affect the traffic. Basically, it's a very competitive field today. People are losing money, and many companies are going to shut shop in India, especially the airline.
But so is in Europe. Air France is in big trouble. You know, they're losing money.
Now the other issue which is related here is that does the country has the right to tax an international kind of a service? The thing is, you can tax your own aircraft, but you cannot tell that I will start taxing the Chinese aircraft or Indian aircraft. That way there will be a lot of retaliation. A lot of the countries will start doing it. If Europe does unilaterally these things, it doesn't stop. China says, okay, I'll put some other tax on you, so I'll neutralize.
Which is normal.
Yeah, but the thing is, right now, this is a new thing, new area, but European Union's main consideration is they want to enforce some kind of efficiency standard. So effectively their interest is not revenue so much. The idea is that how do you reduce pollution. But the thing is, Chinese and Indians are reading, the Americans are reading it as kind of a, you're infringing on our sovereignty. How can you put tax on me? The moment you do it, what stops me from doing the same thing? So that's the right now the consideration which I think European Union is kind of not really going forward with it. I think they're although talking about it in public domain, but I think they are not really kind of not pushing it very seriously. Any other questions? I think we're almost at the time of the next session. Quick questions anybody has? Otherwise,
the graph you had on peak power, can you
peak power?
You had a can you quickly explain this?
It'll take a lot of time, but again I'll try to do. These are two demand curves, peak demand curve and off peak demand curve. And this is your standard marginal cost curve. I'm going to marginal cost theory and all. So you are basically marginal revenue curve, and in two parts will give you the profit maximization. Microeconomics, what is the profit maximizing point? Marginal cost is equal to marginal revenue. So effectively presently what happens? The price is same in peak and off peak hours. Like if you go to Delhi Metro or any other thing, price is the same. What happens then? In peak hours, demand is too much. So if you have the same price, so the price is somewhere in between, what will happen? In peak, demand is this much. In off peak, demand is this much. So what happens to the company? Company is providing, say, public transportation or any other electricity. So what happens? In the peak hours, I am not able to supply enough because I do not have enough capacity. Which means I have to invest so much extra money that my peak demand is met. But peak demand is not for the whole day. So what happens in off peak demand? A lot of my capacity is underutilized, which actually raises my cost of production. So which basically means what should I do? If it is efficient pricing mechanism, that in the peak hours I should charge a higher price, in off peak hours I should charge a lower price. So what happens? The gap which would have been here and here now is here and here. And if you have proper economic strategy, it can be reduced further. And that basically means investment requirement of the company goes down significantly, price realization goes up significantly, so total revenue go up, total cost comes down, your profitability is improved. So overall the sector becomes more profitable. That is the basic idea in this time of the day price.
Does it assume that during the peak hour, by increasing the price, you're reducing the demand or you're increasing capacity?
In the peak hours,
it has two strategies.
No, in the peak hours, what are you doing is the demand is more, and demand is relatively less elastic, which means people are not price sensitive in the peak hours because everybody has to go to the office. They don't care the price is a little higher or price is a little lower. So even if you have price a little higher, the demand will not be very seriously affected. But some people on the margin might shift the demand in the off peak. Like suppose I have to start from home, like in the morning, suppose I am coming, I start at 8 o'clock. But if I see there is a tax on the road, congestion pricing, after 8 o'clock, suppose I have to pay say 50 rupees, but if I start before 8 o'clock, I have to pay say only 20 rupees. Then what will happen? I will possibly start 10 minutes earlier. So that will shift the demand from to some extent, maybe 10% or 5%, from peak to off peak hours. So automatically your demand goes up in the off peak hours, demand slightly comes down in the peak hours. So your overall capacity utilization becomes better and your revenue realization becomes better. So overall you are more profitable. And that's the basic logic, but again, for various reasons, other than few countries, solution is there in the textbook, but we are not able to kind of implement it. I mean, you see across the world, congestion pricing is done only in Singapore, partly in Europe, and to some extent in the US. But no other country of the world does congestion pricing.
Congestion pricing, you mean
if the traffic is too high, then you charge a higher price. Like in Singapore, what happens? The moment you drive a car, you have to put a card in your car. This is your radio frequency card reader. So the moment, what it does is basically the moment you take out your car, the road is very congested, your cost of driving the car goes up significantly. So Singapore is the only country in the world possibly, as far as I know, where there is no traffic jam in the peak hours.
But then it's not peak hour anymore.
Yeah, that's basically. But if you go to any other part of the world, like Delhi, Beijing, Shanghai, London, Paris, any part of the world, this is a simple solution, but again very difficult to put pressure. I mean, Singapore possibly is a dictatorial regime. They have been able to push these economic ideas very easily. But other countries of the world, I mean, now are possibly learning from Singapore as a consultancy. So Singapore possibly is developing as a consultancy hub for economic research. When you have a crisis, will come and help you. So that they are in a way experimenting with this congestion pricing. So now they started in 1960s actually. If you really look at the Singapore history about congestion pricing, they have been very active and they have now developed the technologies which they are now able to offer other countries as an option, and they can buy it off the shelf. You don't have to develop it. But the only thing is, do you have the political will to push it through? And that I think is very sadly lacking. But that is the way solution exists, which we are kind of will possibly adopt it when the crisis comes.
Peak hour in India is all day. Peak hour in India is all day.
Well, the problem is peak hours the whole day is that the price is still low. So what happens? Demand is enormous. The moment you have a differential pricing, then this peak actually will be able to, and you'll be able to generate more revenue, and that revenue will be able to use it to invest more, create more capacity. And that way you'll be able to solve the problem. Like Indian Railways, which is a public sector company, its prices are very low. So what happens? You have to book 3 months in advance any tickets. If you want to go by train, you will not get the ticket. Now it's 4 months. So effectively, if you really want to travel tomorrow, why it is booked in 4 months in advance? Because the price is dirt cheap, and there's no penalty if you cancel the ticket. Unlike airlines, where the price fluctuates almost time of the day. If you go book now or 1 hour later, the price will be different. Like European Railways, they have the time of the day pricing, and they are able to use that to generate more revenue and put it in the railway network, expand it. If you look at India, we haven't had much increase in the railway network in the last 60 years since British left, excepting about 1,000 kilometers overall, which is in the western region of India. Other than that, not much of an increase, because the thing is, you don't have a surplus, and the government is not ready to give you the money. So effectively, you're basically surviving somehow. Your railway is profitable, the profit is about 1 or 2%, which is not enough to generate enough resources to invest. So I feel railway is another example of just like the power sector, where actually you can actually rationalize the use of energy, generate more resources, which can be used to help people for the future.